A quick review. So far this unit, we've talked about this idea. So here's one idea we've talked about. If I take a velocity of, say, 10 meters per second, and I have that velocity for, say, a time period from, oh, I don't know, let's go from 3 to 5 seconds. Therefore, the time period is 2 seconds long. So if I multiply those two things together, someone who'd like free tickets, raise your hand and tell me, what do we get? Simple questions. Jimmy?
20 meters.
So we get 20 meters, free tickets for Jimmy. Someone just tell me, what does the 20 meters represent? Go, Nathan.
The distance traveled in 2 seconds while traveling 10 meters per second.
Really well said. Free tickets for that. I want you to change the wording just a tiny bit, only because we're going to hit some problems in the future where the distance traveled and the change in position will be different. So whenever we are doing, so it can kind of be either depending on the situation. In this case, it's both. But for today, we're going to say change in position. There's a reason I'm doing that. It'll be clearer later, but stick with the word change in position. So the particle's position changed by 20 meters during that time period. It's a perfect name. Another question. That's one thing we've learned. We also learned that if we do this computation repeatedly, like over and over again, say we do this, we integrate from time equals 0 to, say, time equal 40, a velocity multiplied by dt. We're just doing this computation, a velocity multiplied by a change in time, and we're doing it repeatedly. That integral also gives us a total change in position. We get a total change in position for the time period, t equals 0 to t equal 40. Because all the integral really does is it does this computation for a whole bunch of little short time periods and just adds them up. Questions? Okay, give me one or two if everything in green makes perfect sense to you. One or two if everything in green makes perfect sense. You know, don't ever be afraid to give me two if it doesn't. So, 2 points for the room. Cool. The next thing we talked about was, that was the topic from last time. We said, okay, if I have a graph of some sort, and there's maybe some function called f of x, and maybe another function called, I don't know, g of x is very traditional. We talked last time about the fact that we can take a line between the two if we want to find how long that line is, we simply take the y-coordinate at the top of the line and subtract from that the y-coordinate at the bottom. So the length becomes y at the top, subtract y at the bottom. Anyone have a question about that? So then we said, well, since this is on the graph of f, you can find that y-coordinate simply by taking the f function and plugging in the x-coordinate that the dot is located at, then subtract the same thing for the g function. And that would also give you the length of that line. Questions about that? Perfect. We then went on to say, oh, so that means we could actually take and think of that line as a rectangle. This is a line that is very narrow. It's just a narrow rectangle. And the area of that rectangle would be the y at the top, subtract the y at the bottom, multiplied by some small change in x to represent the width. Give me one or two if everything on the board makes sense. So then we said, okay, great. If we want to find the area of many rectangles, we simply need to do this computation repeatedly. So we say, let's take the value of the f function, subtract the value of the g function, meaning the y coordinate, multiplied by a small change in x, and let's do it repeatedly for, say, x equal, I don't know, in this problem up here, maybe we'd say we're going to start right here at x equal 1, and we would keep going until we get over here, maybe x equal about 3. So we start at x equal 1, we go to x equal 3. We do this computation for every x in between, and that means we're integrating. Therefore, this will find a whole bunch of rectangular areas. If you add them all up using integration, you get the total area. So this would be the total area between f of x and g of x for x values between 1 and 3. I have a question. I mean, one or two of that makes perfect sense. Points for the room. Okay, so we've got two things so far that we're using integration for. We're using integration to find change in position. So when we integrate velocity and time, we get change in position. When we integrate basically length, like the length and width, we get area. Today's topic and everything, well, the yellow worksheet actually has some review problems in it. So it has some questions that involve Riemann sums. It doesn't have any area questions since we just barely did that on the pink. But it does have some Riemann sum questions. And then it has the new questions how to do this. It's going to ask you to, so item number 3 on this list, will work. So item number 3 is how do we find, so how to find, oh, welcome back. So how to find, you can put them up here too, Jake.
Okay.
How to find the average value of a function, so say of f of x, for x equal, we'll just say as an example, 0 to 2. It could be something else, but let's go with that for now. So today's topic is how do we find the average value of some function between this x coordinate and this x coordinate? Question on what we're looking for today. Okay, to help us do that, I gave an example on the white sheet. I gave you a function. The function I gave you is x squared multiplied by the square root of x cubed plus 1. So I believe that's what it is. Correct. Okay. So I gave you the handout so it's a little easier to take notes. You can see exactly what the function looks like. Picture is always worth 1,000 words. And actually, this item 3 also matches up perfectly with the yellow worksheet question 3. So we're basically just doing question 3 on the yellow worksheet. Go back to these notes. Average value from 0 to 2 of this function. This word here is a key word. We talked about it in Unit 3, value. Someone remind the class, when they say the value of a function, are they referring to the x-coordinate, the y-coordinate, or both? For hands. 2 points for a good try. There we go.
The
Casey.
y coordinate?
Yes, the y-coordinates. 3 for Casey. No worries. So when they say average value, they mean the y-coordinate. The reason for that is when you look at a graph, you're mostly interested in the y values. The x values tell you where to look to find the y value, but the y is what we're really studying, the y-coordinate. So when they said, here's the function, they want us to find the average value of this function. The good news is what we're doing today really is not that new. We're just taking something you already know and kind of extending your knowledge a little bit. So someone can pick up 3 tickets and tell me, in general, like for example, this is the function we're trying to find the average value of. I went ahead and plotted 10 different points on this function. So I plotted all of these, like 0.2, 0.04, 0.17, 0.4, all the way up to 2, 11.99. So you can see those plotted on your handout. If I asked you to find the average of those, let's see how many there are here. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I asked you to find the average of those 10 values, raise your hand and I'll pay you. What would you do? I'll pay everyone who knows. If I simply said find the average of those 10 values, who knows what to do? Raise your hand. I'll pay everyone who knows. Feel free to talk to each other. It doesn't bother me a bit. Share the wealth. If I say find the average of those 10 values, what do you do? Let's go, Randy.
You add all the values together and divide by 10.
So you add up those values, divide by 10. How many knew that before she said it? 2 tickets, 3 for Randy. So really, this question here says find the average value of the function. The only difference between this question, how to find the average value of the function, and the question when I said find the average of those 10 values, there's only one key difference. Right here, there are only, this one, there are only 10 values shown. So if you add up those 10 values divided by 10, you're finding the average of those 10 values. But this function right here, one hand please. How many values does that function actually have between x equals 0 and way over here at x equals 2? How many values? Who know actually? Okay, everybody. How many values does that function really have between x equals 0 and x equals 2? Ashley. So Ashley is proposing that if we're supposed to find the average value of f, we're supposed to add up an infinite number of values, and therefore we would have to divide by infinity. How many would have said something like what Ashley said? Raise your hand. 2 points, 3 for Ashley. So over here, sorry, this one, that's what we're trying to do. We're trying to figure out a way to be able to add up all of the values of the function and then divide by infinity, essentially. But for today, we really can't do that, so we're going to approximate again. So to approximate, let's go to this picture. To approximate, we kind of start the same way we did with Riemann sums. We use this little symbol dx. The symbol dx really means an infinitesimal change in x. For example, 0.000 forever and then a 1. But it's hard to deal with that type of a dx. So for today, we're going to make dx something easier to deal with, even though it really isn't this. We're just going to choose dx to be, I don't know, 0.2. Any questions? Then what we're going to do is the same thing you just talked about. We're going to say, okay, we want to add up all the values of f, but it's pretty tough to add up all the values. So let's just take some representative samples of f. So if we're considering the change in x to be 0.2, we're going to start right here. We're going to go from 0 to 0.2. So x is changing by 0.2. We're going to pick one value within that interval to represent all of the values, kind of like a Riemann sum, just one value. And to make it easy to talk about, we're just going to pick the value over here at 0. So we're going to say, let's just take f of, so let's write down what we're doing here. So we're trying to find the average value of f for all x values from x equals 0 to x equals 2. And the way we're going to do it is we're going to approximate that by finding from 0 to 0.2, we're going to let f of 0 represent all of the values between 0 and 0.2. That's our starting point. We're going to let f of 0 represent all the values between 0 and 0.2. Let me just go on to the next subinterval. So that would mean, since we went from 0 to 0.2, we want dx to be 0.2. Simple question, somebody pick up the 3 tickets and tell me, if the first subinterval goes from 0 to 0.2, where does the second subinterval go from where to where, Ethan? 0.2 to 0.4. And then following this kind of the same pattern, Ethan, within that subinterval there's an infinite number of y values. Which one do we pick as a representative sample? F of 0.2. 3 tickets for Ethan. Give me 1 or 2 of what we are doing here makes perfect sense to you. We're not finished, but what we've done so far makes perfect sense. Give me 1 or 2. We'll just say it again. Got a few 2s, so no worries. So let's do a couple more, it might help. So we just move on. We say, okay, we've taken care of finding some value to represent all of these infinite values. We found a value to represent all of these infinite values. We now go another change in x of 0.2. That gets us to here. We pick a value within this interval. So somebody new pick up 3 tickets and tell me, of all these different values of the function, which one will represent all of them? Recall. So we take f of 0.4. We say plus. We just go to the next interval. So now we're going from 0.6 to 0.8. We need one value to represent all of these. Somebody else, 3 tickets. Let's go, Casey. 0.6. Okay, we're still not finished. And if you still are at a 2, just show me 2. But how many feel comfortable about what's progressing so far? If you don't, give me 2. Still got a few 2s, no worries. 2 more tickets for the room. We'll keep doing that, but it's getting a little boring, so let's just say dot, dot, dot. We eventually have to get to the very last subinterval. Somebody tell me when would the very last subinterval begin and end for him? The very last subinterval. Let's go Sage. 1.8 to 2. And then within that subinterval, Sage, which value of the function are we going to use following our pattern to represent all of the values? 1.8. So it looks a little funny because we never actually wrote down f of 2, but we didn't need to because the 1.8 is representing all of them. 3 tickets. So here we are. We're finding an average. We find the average by adding up a whole bunch of values, and then we must divide by how many we have. So whole class, follow the pattern and figure out how many terms would we have in total. Because I didn't list them all. So I got a little tired and fell asleep watching. So hands up if you can tell me, how many terms would there be here? Show me your hands. Like we filled them all in. We didn't do the little dot, dot, dot thing. We can count the number of terms we would have. How many would there be? Danielle? Danielle counts 10. So let's just double check. So sure enough, we've got 1. Here's the first subinterval, second, third, fourth, fifth, sixth, seventh, 8th. We have 10 of them. There are 10 terms. How many knew that before Danielle said it? Take us 3 for Danielle. So we need to take all of this divided by 10. Okay, but there's something we want to make sure we do. We want to make sure that you understand how to apply this idea not to this situation, but to any situation. Okay? So rather than write down 10, I'm going to give you a formula. The formula is this. we're finding the average from 0 to 2. So the first thing we do is we say, how wide is that interval? Well, it goes from 0 to 2. You can figure out the width by taking the end of the interval and subtracting the beginning. So I wrote 2 minus 0, but you need to remember this is simply the end of the interval. This is the beginning. Because on the homework, you're going to have a lot of different intervals. Questions about that? So you're simply taking the end of the interval, subtract the beginning of the interval that you're trying to find the average for. Give me a second to make some notes. Okay, what we must also do, though, is divide. Okay, this is supposed to be all of these things added together divided by 10. Well, it's not dividing by 10 currently, it's dividing by 2. The way we make it become divided by 10 is we divide this by the width of each subinterval, or our little dx value. Because what is, just say it out loud, what's 2 divided by 0.2? 10. So this is the formula you're going to use on every problem. It's always the end of the interval minus the beginning of the interval divided by whatever dx you've chosen. So we have what we set out to do. We have all the values added up, and we're dividing by how many values we have added up. I mean, 1 or 2 of this equation makes perfect sense to you. One or two of that equation makes perfect sense. Points for the room. Tell me what part was funny. Because you're good at questions. Oh, perfect. Totally random. Totally random. No, it's an awesome question. We needed some value in here to represent all of them. We could have picked one on the left. We could have picked one on the right. We could have picked one in the middle. We could have been really creative and picked one right here. It doesn't really matter. Is that okay? Any other questions? Everything else okay? Great question. 3 tickets. Anybody else? Perfect. Okay, next step. Okay, again, I'm trying to show you how to accomplish this for any problem, not just this one. So we're going to do something different now. Rather than take all of these things divided by this, and why we take the next step will become apparent about 2 steps after it. Somebody remind the class, you've done it many times, when you have something divided by a fraction, what is that equivalent to? What's another way to write something divided by a fraction? Ethan? Multiply by their reciprocal. So that means this average value can be rewritten as f of 0 plus f of 0.2 plus f of 0.4, and I'll leave out the 0.6, just do dot, 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 f of 1.8, and all of that multiplied by this reciprocal. So that would be 0.2 divided by 2 minus 0. It's really important that you keep writing 2 minus 0. Because you don't want to forget, this is always the end of the interval, subtract the beginning of the interval. Any other questions there? When you multiply fractions, you take the top multiplied by the top and the denominator multiplied by the denominator. So the denominator will stay at 2 minus 0 because this denominator is 1. Then what we do is this needs to distribute. So we get f of 0 multiplied by 0.2 plus f of 0.2 multiplied by 0.2 plus f of 0.4 multiplied by 0.2 plus dot, 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 f of 1.8 multiplied by 0.2. And the whole thing is still divided by 2 subtract 0. 1 or 2 of this equation right here makes perfect sense to you so far. 1 or 2, if you're happy with this equation, like, yep, makes sense, I'm good, I'm following the discussion, have any questions? This is way ahead of us. She fell asleep. Usually when you say the name, they wake up, but they must be very tired. Okay, 2 points for the room. Question. Okay, one person, look. Ignore the denominator for a minute. Focus on the numerator. Look at where the numerator came from. Like compare this series of terms to what you see here, and somebody raise your hand and remind the class of, like, what is this reminding you of? What does it appear to be that we have written in the numerator right here? It's something you've seen before. Compare the numerator to the graph. I'm hoping at least one of you can say, hey, wait a minute, I've seen that before. It's such and such. I'll just take a little break over here. Ethan's in for 3. Anybody else in? Jenna's in for 3. Casey's in. 3 more McCalls. And you can talk to each other. I don't care. Sarah's in. It should remind you of something you've done. All of you have done this before. I'm hoping it'll remind. Nathan's in. Smooth's in. Oh, Nathan and Nathan. There you go. Sage is in for 3. Who else knows? I'll make sure slowly goes back down. Kind of awkward. So, Sierra, what does it remind you of?
The gold paper, like the integrals and stuff.
Very good. Like I call it the buff one, but yeah,
Buff.
that would be yellow.
Sorry.
There you go. 3 points for Jenna. Good work. This one, eh?
Yeah, that
Perfect.
one.
Perfect. On this paper, you were doing, like every single problem is asking you to do what kind of mathematical computation? It's a Riemann sum. The Riemann sum is actually a method of doing a different computation. Every problem is asking you to do what's called an integral. And the Riemann sum is the method of approximating the integral. Okay, so give me 1 or 2 of what I just said makes sense. Everything on this paper said do an integral, and then Riemann sum was the method you used to compute the integral. 2 points for the room. Sarah is correct. This should have reminded you, right here, of a left Riemann sum. Because we went to the first subinterval, we picked one value within the interval, the one, as Miley said, on the left, that's x equals 0. We plugged that into a function, and then we multiplied by the dx for that interval. The change in x was 0.2. We did it over and over again for an entire interval from 0 all the way to 2. All this is in the numerator is it's just a Riemann sum approximation of an integral. It's a left Riemann sum approximation of an integral. That's all it is. So raise your hand if you would have said something like what Sierra said before I called on her. 3 tickets, cool. 3 for Sierra. 4 actually because she was the voice. Questions? So now what we want to do, this gets really difficult to write. Like if your homework involved writing this and then this and then this, there's 18 problems, 18 different times, you'd be a little bit unhappy because it's kind of tedious. So instead we say, hey, the average value can be approximated as actually we don't need approximation anymore. So we're going to fix that. So the average value, let's change color too. So the average value, scroll down a little bit. Of f of x. The formula I'm writing in blue, you will need to have this formula memorized forevermore for the rest of the year. And you've got to make sure you understand how to use it because it's going to show up in lots of different problems. Average value of f of x for x equal 0 to 2 is just an example. Okay, the average value can actually be found exactly. It's not an approximation. By simply integrating. Okay, to integrate means to multiply, add, multiply, add. So one person or more, raise your hand and tell me, in this big long numerator, what is being multiplied then added, multiplied then added, multiplied then added? Look at it. Hands please. In this big long numerator, what are we multiplying, then adding, then multiplying, then adding, then multiplying, then adding? You can't say it mathematically, it doesn't matter. You just have to be able to kind of point out in common sense language what's being multiplied and added and multiplied and added right there. All knows. Your hand is raised, you're paid. Let's go for Tyler.
Is the d of the dx times the point that we take?
Very good. So Tyler noticed that here's a dx multiplied by a value of the function, a y-coordinate of the function. Here's dx again, multiplied by the y-coordinate of the function. Dx again, different y-coordinate. So all we're doing is we're taking function values, f of x, we're multiplying them by a dx. That's all we're doing. Taking a function value multiplied by dx. We just do it over and over again. And then we add them all up. So would have said something like Tyler before he said it. He points to for 4 for Tyler. So. We still have to take care of the 2 minus 0. So we put that underneath all of it. Now, we wanted to start doing this multiplication at what x value? Someone? 0. 0. So we put right here x equals 0. And Sierra, we want to start at x equals 0. Theoretically, we'd like to plug in every possible x value, doing this type of computation for like 0 and then 0.1 and 0.2, etc. When do we want to stop at, Sierra?
X equals 2.
X equals 2. 3 points for Sierra. I have a tendency to want to make jokes about things I hear people say, so I was very tempted to say that, it sounds funny to say I was tempted to say and I'm going to say it. So I overheard Sierra when they popped it. He was like, who's that hot girl in the corner? 3 points for the hot girl in the corner. Good work. All right. Hope that didn't sound offensive or anything. Okay.
That's funny.
All right. I was a little reluctant. I didn't want to offend anybody. Questions? Questions?
Oh, about your picture of the hot girl.
Questions? I overheard her saying that. Questions? Oh, please.
So the average value of fx is kind of like it's the change in position over change in time. Is that what it is?
Interesting way to think of it. No, it doesn't really, hard to equate that, to be honest. Because in this example, f really is just some function. To me, the better way to equate it is by doing this. Now, what I'm going to show you, Ethan, is not mathematically legal, but it does basically illustrate the idea that this means to perform this operation repeatedly and then add them up. So since the dx is common, it's like it never changes. It makes common sense, even though mathematicians won't ever do this, to say, well, let's just take the dx out of the integral, put it out front. So then what you'd have is you'd have this thing to just add up all the f values, which is what you want to do when you average. With the dx out front, you can then flip it back to the numerator, and you end up with this kind of a thing, which again is not mathematically correct, but it does illustrate the idea. You'd say, let's add up all the f values. Like, you can't get your calculator to do that, it won't. Add up all the f values, then divide by 2 subtract 0 over dx. Because this will compute perfectly how many values you have added up. Does that make sense? That's why it's an average. Does that help answer your question? 2 points. So that's essentially what's happening. Although this, again, is not mathematically correct. Anybody else? Cool. So all you have to do now is figure out how to use this on different problems. So we'll do some examples. So going to the yellow sheet, I look at problem 3, and it says, find the average value of this function on this interval. So understanding what the formula means and what the question is asking, I simply write on my paper this. Average value of f, x equals 0 to x equal 2 is going to equal the integral of what we're averaging multiplied by dx from x equals 0 to 2. And then I must also divide that integral by the width of the integral. What's the span over which I'm finding the average to subtract 0? Questions to there? Give me one or two if this purple makes sense to you. One or two if the purple feels good, makes sense. Welcome back. All right. 2 points for the root. 2 points for the root. This goes back to Jenna's comments, 3 points for a royalty comment. Jenna said that in the buff sheet, the buff homework, that we were doing Riemann sums. And what we really were doing is we were finding integrals values using a Riemann sum method. In this problem, it doesn't say to do a Riemann sum method, therefore, we're just going to use our calculator. Okay? So we're just going to use our calculator. Therefore, it really won't be exactly equal, but pretty good, because the calculator chooses a very small index. So everyone, do this on your calculator, and I'm just going to leave the answer blank for a second, but get it done on your calculator so you can make sure you know how to get it done on your calculator. If you have trouble, just ask. So. Just do the integral first, press enter, then divide. You can do it another way. It's a little more mistake-prone. So just do the integral, enter, then divide. You could. I still think it's safer just to integral, then divide. It does work too. So you can use the fraction bar and put the integral in the top of the fraction. Is that what you meant?
Yeah.
Yeah. So far, I was a little nervous for a minute, but we recovered.
Okay, so I did the integral first, and then divided by 2, and I did it that way too.
No, it should be the same.
Is that it?
It's just this is giving you the fraction, it's the decimal. That's all it's more calculator. Oh, no different. So this is where you're free to get the answer. So what is the answer supposed to be? Just look at that. So that would just be 26 divided by 9.
Oh, okay.
Great question. We can do it all.
I think so.
Go to
So wait, we can do all of our work on the yellow paper?
What's that?
We can do all of our work on the
Oh, yeah, thank you for the question. Sierra asked a great question, 3 tickets. Look up. In previous units, it was just due to the type of problems. I was having you write the problems in your notebook and then solve them. For this unit, that gets kind of cumbersome. So to help you out, plus we're doing fewer problems per packet. So these packets, you're free to do the work on the packet. Makes it a little bit easier. So thank you for asking. Raise your hand if you have the correct answer. What did you get, Richard? 2.889, which basically is the. So, how many got it right? 2.3 for Richard. Do we have a question? Do one more example. Let's go look at. Look at number 6, please. So go to 6. Please go to 6. Go to number 6, please. Okay. Remember, you're doing lots of FRQs in this unit for homework. So remember how FRQs are structured. They always give you information alone, no question, and then the question is always in part A, B, C, D. So all of this to here, and so all of this is just information. So with experience, you kind of choose what you like doing better. Some people like to read first. Some people like to just go to the question, look back for information. It kind of depends on your personality. So I'll just start with the question. Approximate the average temperature. So then I go look back up here to orient myself, and I say, okay, they're using W of T to represent temperature. So just make a note to myself. So W of T is the temperature. We're supposed to find the average temperature in degrees Celsius of the water from time 0 to time 15. So I write down average value of W of T for T equal 0 to T equal 15. Now that's going to equal, I know exactly what to write. Somebody tell me, if I'm trying to compute the average value of the function W from 0 to 15, what's the memorized formula that you're always going to use to find the average value of anything? Like, just tell me what to write. Sage.
So integral sign, and then x is equal, or t is equal to 0,
T equals 0 to T equal 15. Going.
And then all over. Would that be t of 15
Just 15. Minus 0. So the end of the interval, the beginning of the interval. 3 tickets for Sage. Give me 1 or 2 if this makes perfect sense. 1 or 2 if this makes perfect sense. 3 tickets for the ribbon. Okay, now we keep reading. Notice something. Hey, look how this is scored. Remember, with FRQs, you get points for getting partway through, as long as what you're doing is correct. So if you look at the scoring guide in the back for number 6, oh, they were a little bit cheap on this one, the 30 rats. I was hoping for 3 points. I was hoping they'd give us a point for the integral. They didn't. Sometimes they do. So they didn't give us a point for the integral. Oh well. We wrote the integral. Now we're supposed to find the value of the integral using a trapezoidal-Riemann sum where the change in time, or the dt, is 3 days. So I go back up to the table, and I say I'm supposed to go from 0 to 15, just like I've taught you. I'm supposed to go in increments of every 3 days. Like that. So I'm supposed to approximate this by the trapezoidal method. Now, we're going to do the integral first, then divide by 15. So a good way to write this is like this, say approximately equal to. Okay, dividing by 15 is the same as multiplying by 1 over 15, and it's a little easier to write. So just pull out the 1 over 15. Pretty good with that. Okay, with trapezoidal, remember you go to the first subinterval, you have to pick both the left and right values. So I write W of 0 plus W of 3, and then all of that gets multiplied by a half, because that's how trapezoidal sum works. And then it all gets multiplied by the width of the subinterval, which is also 3. And I have to do some more terms. I mean, 1 or 2 of this in purple makes perfect sense. And how to find the trapezoidal Riemann sum. 1 or 2, please. So some people have just forgotten how to do the trapezoidal, so let me just say it again. 2 points for the room. Does anyone have a question about the 1 over 15? No worries. So all I did was say, I'm supposed to find the value of the integral, and then I'm supposed to divide by 15. But dividing by 15 is the same as multiplying by 1 over 15. So I'm just going to take 1 over 15 and I'm going to go find the integral. Good question. 2 tickets.
I'm just wondering, what's the difference between the median and the trapezoidal if you're adding the smallest and the largest and dividing by 2, or just having the median?
Oh, the midpoint, it's just a matter of words. So midpoint literally means find the value that is just in the middle, which is the median.
Okay.
What we're doing here is actually the average of the first and last, which is just the average of the first and last.
Okay, so
So it feels like a middle, but it's not the same.
Okay.
Is that okay?
Yeah, that's with like Riemann sums, right?
Yes, so for Riemann sum, if you're doing a midpoint Riemann sum, you're just finding the middle value within the subinterval. And if you're doing a trapezoidal, you're finding the average of the first and the last. So the bell's going to ring, but to finish this, you just have to finish the trapezoidal sum, as you learned in the rough packet. And then you have to work. The homework is the yellow packet.
All of it?